Okay, I've got all my colors lined up, and I used green for the y equals x squared graph, so I'm going to use green chalk to construct that graph. And it's very easily done. When x equals -2, x squared is 4. So we plot -2 here, 1, 2, 3, 4 here. We bring those together so that the y value here is 4 and the x value is -2. And then -1, 1. Well, -1 here, 1 here. There's our point. And we have 0, 0, and we have 1, 1, and we have 2, 4. And we also have -1/2, 1/4, and +1/2, 1/4. So when we come in here to the halfway point, our value is only 1/4. And we see that the graph appears to flatten out pretty well instead of coming down and making a point or something. And if we follow the trend of these points, right there is our graph. Okay. Now the next graph we want to make is that of x cubed, and we're going to use orange chalk. Okay. X cubed shares some points. The graph of x cubed shares a couple of points with the graph of x squared. It shares 0, 0, and 1, 1. So we have 0, 0 here and 1, 1 here. Now those are the only points it shares. Now halfway between 0 and 1 is 1/2, and x cubed is 1/8, which is only half of the 1/4. So the x cubed is down here, twice as close to the x-axis as the value of the x squared. Okay, well, the graph is going to, again, shares these 2 points with the y equals x squared graph, but it's going through a point here that's lower, so it's going to be a little flatter when it starts, but it's going to come up through here, and then let's see what it does after that. Okay, so when we get to x equals 2, our y value is 8. Well, that means 2 is going to line up with 8 all the way up here. And our graph is going to start out lower than the graph of y equals x squared, but it's going to turn and become much steeper. Now, on the other side of the x-axis, we have the same numbers, except they're all negative. So we can construct that when x is -1/2, x cubed is -1/8. -1/8 is going to be, well, -1/2 of course is over here, and -1/8 is going to be here, pretty close to the x-axis. Then we're going to have -1, 1, -1, -1, and -2, -8. So on this side of the graph, we have very similar behavior. It starts out pretty flat, and I didn't make it flat enough there, but you get the idea. And then it kind of gets very steep in the negative direction. Okay, so we have our graph of y equals x squared and our graph of y equals x cubed. Now we can see the same graphs. Here's the x squared graph in smaller form, and the x cubed graph. Now we want to construct the graph of y equals x squared plus x cubed. And I've got that graph down here in yellow. Let's see how we can construct it. Okay? Okay. The y equals x squared graph is this high at x equals -2. The y equals x cubed graph is way down here. Okay? If we add the y value here, that means we're adding a value that's this big, going in this direction, to a value that's this big, down in this direction. So we're going to have to add this value to this value to get the value of our x squared plus x cubed. And of course, I didn't do a great job of that. This should have lined up with -4, which is, of course, the value of x squared plus x cubed. I didn't want to read that off of the table, although I could have. I wanted to see how we would construct that. So we would take this, which is a positive value, and add to this negative value, and we would get then -4. Now, as I say, I kind of missed, let's see, 1, 2, 3, 4, 5, 6, 7, 8. There's 4, -4. So if I'd done that a little more accurately, or if I'd had the graph drawn a little more accurately, that would have been here. So we come down here. Actually, that's actually a little better. Okay. Now, do we understand that what we've done here, we can represent this y value by an arrow, and we can represent the y value of the x cubed function by an arrow. So this is an upward arrow indicating a positive value. This is a downward arrow indicating a negative value. If I take this upward arrow and put it down here, then I've added the negative number to the positive number, and I've gotten this value. Okay? Now, of course, the numbers are, this number is 4, this number is -8. -8 plus 4 is 4. But visually, we can always add the height of this graph to the height of this graph, where height can go negative. Okay? So what do we do here for x equals 1? Well, we have a positive value that's this big, and we have a negative value that's this big. They're the same size, so they add up to 0, which means that we're going to have this point on the graph. And of course, that coincides with what our table tells us. When x is -1, y is 0. Then let's skip the -1/2 just for a minute. We go to the 0, 0 point. Obviously, both x and y are 0 here. So when we add them, we're still going to get 0. So we're going to have a point on the yellow graph at 0, 0. And then at x equals 1/2, both graphs are pretty close to the x-axis. The one is 1/4 of a unit above, the other point is 1/8 of a unit above. When we add those, we get a point a little bit higher than the value of x squared. When x equals 1, both the x cubed and the x squared functions have the same value, so we add that value to itself to get the value of our x squared plus x cubed function. And then we do the same thing here. We have this value, which we've got to add to this value, giving us a point way up here. Now, the only point we don't have is the point where x equals -1/2. What do we see? Well, the value of the x squared function is 1/4. The value of the y cubed of the x cubed function is -1/8. So the y value of the x squared function is bigger than the y value of the x cubed function. And it's okay. Well, the y value, the positive y value for the x squared function has a greater magnitude than the y value of the x cubed function. So we're going to get a point that's above the axis, because again, the green graph is higher above the axis than the orange graph is below the axis. So we're going to get a point a little ways above the axis, and actually the coordinate of the point is 1/8. So our graph through these points is going to come up here. It's going to get pretty level here. It's going to come down to the origin, and then it's going to turn around rather quickly and start up, and then it's off to the races. So here's our graph of x squared plus x cubed. Again, we need to be able to ideally look at these two graphs and see point by point how they add up, so that we can visualize the sum of the two graphs. We can always make a table, we can always get values on the table, but being able to look at the graphs and add these in that manner is quite valuable.